Hi friends, welcome back to new session. In a previous session, we explained the effect of leakage flux on the operation of transformer topic and how we have to refer reactances from one side to another side. Here, in this session, we'll discuss about here we'll discuss about Lorentz-Force law and forces between conductors, forces between conductors. Forces between conductors. That too, here one more thing. Forces between conductors. Okay, if conductors are placed in same limb, if conductors are placed on same limb. Second one, if conductors are placed on different limbs. We'll see. Before that, just see, you just take two parallel conductors carrying current in same direction. You please take two conductors carrying current in same direction. So like this. This is nothing but conductor carrying current in this direction. This is one more conductor carrying current in the same direction. So our topic here to here. Okay. Right. Yes. Here, suppose guys, if observe clearly, if I1 is the current flowing in this conductor, if I2 is the current flowing in this conductor, and pi1 is produced in this conductor because of this current, pi2 is produced in this conductor, I mean around this conductor because of that current I2. So, if you observe clearly, if current by the right hand thumb rule, if current is carrying, if a conductor is carrying current in the same direction like this, for a straight conductor, you can take thumb by the direction of current like this upwards. What might be the direction of your flux? I can say anti-clockwise direction like this. This is direction of your flux pi. Okay, pi 1. Okay, now similarly you can show with this symbol, and here also, if suppose current is flowing in this direction, what is the direction of your pi 2? Anti-clockwise direction like this. Now tell me, here what is the direction of your pi 1 and pi 2? They are opposing or they are aiding? In this case, these pi 1 and pi 2 are opposing or they are aiding? I can say they are opposing. Therefore, your resonant flux becomes pi 1 difference pi 2, nothing but the weak flux. It's a weak flux. Whereas here, here pi 1 is flowing. Here pi 1 minus something is it. That means here strong flux is there. Here only pi 2. Here pi 1 difference pi 2. Therefore, obviously here also you can say that strong flux is there. Okay, and always resultant forces will be from strong flux to weak flux. This weak flux Strong to weak means it will be like this, strong to weak. So they are coming towards. That means I can call it as a attractive forces. So I can give one statement here. According to Lenz's law, according to Lorentz force law, according to Lorentz force law, first statement, if two parallel conductors carrying current in same direction, then attractive forces, okay, attractive forces, F attractive means attractive forces exists between conductors, the one statement. Now similarly, suppose once again let me take one more conductor here and one more conductor here. Let me take two parallel conductors here once again. If they carry current in opposite direction like this, I1 and I2 like this is what I can say. Pi 1, here pi 1 is produced around your conductor. Here pi 2 is produced around your conductor. If current is flowing upwards, direction of your flux will be anti-clockwise direction. So like this. What about here? If current is flowing downwards, what is the direction of flux? Clockwise direction. So now tell me here pi 1 and pi 2 are they aiding or opposing? Here in this case they are aiding. So I can say that pi 1 plus pi 2 is happening here. Nothing but I can say strong flux. There is common sense that here pi 1 is only the flux here, and here pi 2 is the only flux, but here pi 1 plus pi 2 is the flux. So obviously this becomes weak flux, and here this becomes a weak flux. So always resultant forces will be from strong to weak. Therefore they are going, they are not coming towards, they are going away from me. Their force are like this, okay. Therefore this force can be called as repulsive forces. This statement only I can write it as a second point. If two parallel conductors carrying current in opposite direction, then repulsive force exists between, conductors, okay. Let's note on this. Right. So I'm just going to erase this one. Please try to remember that if two conductors carrying current in the same direction, attractive force will be there. If two conductors carrying current in opposite direction, repulsive force will be there. This will be useful for us in solving one question. Okay. Here. In this question, he asked, he has given P winding and S winding. He just placed P winding on one limb, he just placed S winding on another limb. This one limb, this one limb. He just placed P winding on one limb, he just placed S winding on another limb. That means two windings placed on two separate limbs like this. See, placing one winding on one limb, one more winding on one limb like this. Okay. Now what is asking? He has given you direction of current in P winding as cross and dot, and is asking one question. What is that? So in S winding, for this direction of current, if dot is given, cross is given, for S winding, where dot should be there, direction of current, where cross should be there. Indirectly, what is the direction of current in two windings? Same or opposite is asking. Same or opposite? If I place windings on two separate limbs like this. And what are the forces we are going to have between those two conductors is asking. Very simple. What is that? Suppose you tell me if current is entering like this in P winding, cross entering, I told already, right hand thumb rule, cross means entering, dot means leaving, like this, entering, leaving, entering at the cross, leaving at the dot. What is the direction of your flux? Upwards. Therefore, this is the direction of your flux, pi p, pi p, pi p, pi p. P winding related flux, I can say. Okay. Now, according to Lenz's law, this is very, very important. According to Lenz's law, what we discussed already, whenever this pi is coming and linking with this winding, here some EMF will be induced and current will flow in such a way that because of this phi 2, whatever flux phi 2 is coming, that phi 2 has to oppose previous flux pi that we already discussed. Therefore, now ultimately in S winding some EMF will be induced because of this pi p. And because of that EMF, current will come. Example, let me take IS current. IS current came. How that IS current will flow means, it will flow in such a way that because corresponding to the direction of your IS, pi s will come. That pi s has to be upwards because pi p is coming like this. It has to oppose, pi s has to oppose your previous flux pi p according to Lenz's law. Therefore, obviously, your whatever pi s is there, that should be opposite to your pi p, opposite to your pi p. Okay, this is what I can say, pi s, it should be upwards. If it is upwards means, where current has to enter in S winding, where current has to enter means ultimately, where current might have entered, corresponding to which your pi s is upwards. It has to enter at here, it has to enter, it has to enter here, it has to leave here. That means entering means this becomes cross and this becomes dot. So like this you have to decide the polarity, okay, for S wind. Now tell me, direction of current, dot cross, here S winding, dot cross, same or opposite? Same. If you are having confusion, you do one thing. You please try to see, because of this P winding current entering cross dot, flux is upwards. At that instant, flux is upwards. Here, because of this current, S winding current, cross dot, at that instant is upwards. Two flux are in upward direction. So obviously, current also will be in same direction. If this current, because of P winding current, flux is upwards. Because of S winding current, flux is upwards. This black color, this red color. Those two are in upward direction. So obviously, same direction. So direction of currents also will be same. You please don't see here, and the core it might be opposite. They are opposing the core. If you want to decide the direction of current in P winding, S winding, so dot cross dot is clearly visible. Suppose if you are in doubt, you can decide by seeing the direction of your flux at that instant. Whenever current is entering and leaving, at that instant is upwards is there. Don't see here, upwards. Here only you have to see. Here cross dot entering, at that instant current is flux is upwards. Yes, both flux are upward direction at one particular instant. So direction of currents also will be same. So I can write here one conclusion here. What is that? You can write one conclusion corresponding to this. If two windings are placed on separate limbs, like this, to satisfy Lenz law, direction of current, in two windings is same or opposite? Is same. And previously I told one topic, if two windings carry current in same direction, then what are the forces we are going to have between those two windings? Attractive forces, okay? And attractive forces exist, between two windings. This is the conclusion. Suppose if we place, instead of like this, suppose if we place windings like this, that means what? On the same limb I just placed P winding, on the same limb I just placed S winding also. If I place P winding and S winding on the same limb, then if you have given direction of current in P winding, cross and dot, same question I'm asking. What might be the direction of current in S winding, same or opposite? Or what are the forces you are going to have between these two windings? See, in real-time application also, don't expect that winding transformer will be like this. Entire one winding and one limb, it will not be like this. Real-time application point of view, winding will be, example, if I want me to show, I can show like this. In terms of LV and HV, if you want me to say, in terms of LV and HV, to reduce leakage flux, because here see example, here leakage flux is there. So leakage flux, if you want to convert that leakage flux into useful flux, what do you have to do? You have to make arrangement such that your pi L1 has to link with your this winding and this winding, then it becomes useful flux. So for that only, generally instead of placing entire one winding, low voltage, example, let me take this one is low voltage, high voltage winding, entire low voltage winding on one limb, entire high voltage winding on one limb. Instead of placing like this, what do you have to do? Placing LV winding half on one limb, remaining half another. Placing half of HV winding on one limb, remaining on other limb. There is no electric connection between these two things. This HV by 2 and HV by 2. If I place like this, what will happen at that time? Suppose if a leakage flux is there in your LV winding, previous case it is taking path of the air, because here to this near to this LV winding there is no HV winding, but now near to LV winding HV winding is there, so it links with your HV winding, so that means it links with both windings, it becomes useful flux. So real time application, generally on one limb you will be having both LV and HV will be there. Like that here he just placed it on one limb, instead of placing P winding on one limb, S winding on one limb, he just placed P winding on one limb and S winding also on the same limb. Now if I place winding like this, now what might be the direction of your current in S winding and what are the force we are going to have between those two windings? This is the question. Okay, very simple. Now here also, suppose in P winding direction of current entering here, leaving here, so flux upwards, phi P is upward direction, it is coming like this, it is linking with your P winding, EMF will be induced here, that is okay, and same flux will come and like this, it will link with your S winding also here. Here S winding will be there, no, it will link with your S winding, EMF will be induced as usual, just like pi is coming and linking with your secondary winding, EMF E2 will be induced, no, like that here also some EMF will be induced here. Let me take it as ES. Because of that ES, you will be getting some IS. IS will flow in such a direction. Because of IS, water flux of pi S, here you can say pi 2, pi S will come, that pi S has to oppose previous flux of pi, here pi S has to oppose previous flux of pi P. So previous flux pi P means upward direction. Now your pi S should be downward direction, then only you can say that it is opposing your pi P. This is the direction of what? This is the direction of pi. Yes, pi S. That means pi S, this red color should be downwards. Downwards means where current might have entered here, cross, entering into the board, coming from the board, cross, dot. This is cross and this is dot. Now tell me, if I place windings like this, if I place windings two windings on the same limb, to satisfy Lenz's law, direction of current is same or opposite? Clearly it is visible opposite. Dot cross, here cross dot. Or if you want, you can see it, depending on the flux also you can say, correspond to P winding current, at that instant flux is upwards. Here because of S winding current, at that instant flux is downwards. So downwards. So obviously these two are opposite, currents also opposite, or clearly it is visible dot cross and this cross dot. So I can give one note here. Similarly, whatever you have given previously, like similarly, if two windings are placed on same limb, to satisfy Lenz's law, direction of current in two windings, is opposite. Now tell me, already I told you, if two conductors carrying current opposite direction, you will be having repulsive force or attractive force? Repulsive forces. And repulsive forces exist between two windings, okay, just note down. Yeah. Let me ask you one more question. Once again, see, let me ask one question here. See, for these two figures, definitely these two figures are different. They are not same. Because observe clearly, in the first figure, this is what I can say your front end, this is what you can say back end, your front end, back end. And here front end, back end, here it is back end, and it is front end. And in our discussion, I think we already discussed. In our discussion we are placing, we are taking front end as beginning end, back end as ending end. Front end as beginning end, back end as ending end. Here front end as beginning end, back end as ending end. Here front end as beginning end, back end as ending end. And we already assumed dots at the beginning end of a coil. So beginning end of a coil means this one, dot. In this coil beginning means this one, dot. Here beginning end means this one, dot. Here beginning means this one, dot. Okay. So for this question, sense of winding is from this figure to this figure, sense of winding front end, back end. But here it is a front end, here it is back end, nothing but front end. Now for this question, which one is here load, which one is phase, which one is neutral? Actually, whether this is, phase is this one or this one, neutral is this one or this one. Similarly, he is asking question here also, phase is this one or this one, neutral is this one or this one, like that he is asking question. So actually first diagram is this one only. Observe clearly, diagram, okay, voltage source, okay, front end, yes, front end, back end, yes, back end, front end, yes, front end, back end, yes, back end. Same figure, dots, we just assume at front end here, same question. So here we already made discussion, the current is flowing like this. Current always flows from phase to neutral at load. Current always flows from phase to neutral at load. Therefore, here current is flowing like this. This is what I can say phase. Current is coming like this, no, arrow mark. It is going like this. Therefore, phase and neutral. So obviously, here phase and here neutral. So your answer here also I can say phase and neutral. That's simple. Or if you want me to explain that once again like this, yes, I can see, like you can explain like this. Observe clearly. First of all, it will take some current, I mu it will take. Same thing, whatever I explained here, that I'm just repeating here, that's it. So whenever current is entering at front end, it is entering at front end means direction of current in front end. Current is entering at front end, leaving at back end, entering at front end, front end, front end. It is entering like this, no? Current is entering like this, leaving like this. That means cross and dot here. So at that time, whenever current is entering like this, flux will be upwards. So flux will be upwards. This is what I can say, direction of your flux, upward direction. And this flux is linking with this winding, EMF will be induced here. Because of that, current will come. How current will flow? Because of that current, whatever flux, example pi 2 is coming, that pi 2 has to oppose previous flux pi. Here, previous flux pi is like this, downward direction. So, your whatever flux we are getting, I mean I2 current, it will flow in such a way that your pi 2 has to oppose previous flux pi. This is what your direction of your pi 2. Now if I want to have direction of pi 2 like this, in what direction I2 might have entered? If our flux is upwards, in what direction our I2 might have entered means it has entered at a back end. See, if I show you like this front end, it is back. I'm saying clearly, I'm showing it's a back end, right? Back end. So that means at a back end, you have to set back end direction of current. It is like this. It is entering at back end like this, leaving at front end like this. Yes. Now current flows from phase to neutral. So that's why this phase, this is neutral for this question. And observe clearly, I told you current is entering at back end and leaving at it is entering at back end, leaving at front end, no? So cross dot. See, dot cross, dot cross, dot cross, dot cross. Same thing I explained there. Observe clearly, current is entering at the dot here in this coil. In this coil, current is leaving at the dot. So which type of coupling? I told in our previous session, in our last discussion we just made, if current is entering at dot in one coil, if current is leaving from the dot in another coil, that can be called as a negative type of coupling. Yes, negative type of coupling only, this one. So not only similarly with this knowledge, I think you can tell answer to this question. So please try to respond. This is what I can say. I mu once again. It's entering at front end. Means it is entering at front end, leaving at back end, entering at front end. Or I can say direction of current is entering at front end means this becomes cross, this becomes dot. Three-dimensionally, if you want, so I can show like this. And if current is entering like this, direction of flux will be upwards. So flux upward means it will be upwards like this, upward direction. And here this pi and is coming and linking with this winding. Here, as usual, whatever, because whenever this flux is linking with this winding, EMF will be induced, and direction of that EMF will be is nothing but direction of EMF or direction of I2 will be such that because of I2, whatever flux will come, pi 2 should oppose previous flux pi. That means, as usual, once again, is pi direction is like this black color flux lines. And what about pi 2 should oppose your previous flux pi? So it should be like this. That means if you want direction of your pi 2 upward direction, where current might have entered at back end. Back end direction of current is like this. Front end it should be like this. So current is entered at back end means it is entering at back end. It is entering at back end, leaving at front end. Leaving front end like this. And as usual, also current is entering at back end, leaving at front end means, so I can show this in three-dimensionally cross and dot. Now here I2 current is entering like this, okay, and it is leaving here. Now it is coming from here to here. So this becomes phase, this becomes neutral. I told you, always current flows from phase to neutral. So current is coming like this. If this is your phase, this is your neutral. And you observe clearly, previous direction of I2 is like this. Now I2 is like this. Previously current is entering a dot. in this coil. Current is leaving the dot in one coil, another coil. In this figure also, current is entering the dot in one coil. Current is leaving the dot in another coil only. Here also negative type of coupling only. Negative type of coupling, negative type of coupling. But here phase is this one, neutral is this one. Here neutral is this one, phase is this one. Okay, just note. Type. Okay. Now here, I'll take one simple topic here. Don't worry. Suppose this topic, if you are not able to follow, also nothing happen, because already you know that angle between your V1 and E1 is equal to how much? 180 degrees. Already you know this, right? You know this. But I'll because of Lenz's law, we already from the waveforms we conclude that V1 and E1 are displaced by 180 degrees. That's okay. But please try to listen this topic also. But please try to follow. If you are not able to understand also, nothing will happen. It's not that much important. See guys, very simple. For understanding this, I mean, I just want to know how your E1 is V1 is nothing but cause. This is E1 is nothing but the effect. How this effect is opposing your V1. Why I am using symbol V1 bar equals to minus V1 bar. Minus symbol, why I am just keeping. For that I am just giving explanation. I am just trying to give. See, actually, if you know already, if source is there, if it is a plus, if it is minus, always current is leaving from positive, it is entering at negative. Current is entering at negative, it is leaving at positive. That is the only thing, no, regarding source means current has to enter at a minus, it has to leave at a plus. Okay. If you see this one, this same, this portion only I am just explaining. This portion only I am explaining. This portion only I am just going to explain. Please try to follow. This voltage is nothing but plus minus. Current is entering here. It is leaving here. So this portion I am just taking here. Voltage source nothing but plus minus V1. Nothing but current. Let me take I mu. Yes or no? Whenever if I connect some voltage source to this primary winding, so current is source means current has to leave from a positive terminal. It just left like this. Now you know guys, here direction of I mu I already discussed. Please try to go for this topic once, okay, before understanding this. Current is entering at the front end, so direction of your current is entering at front end, leaving at back end, entering at front end, leaving at back end, entering at front end, leaving at back end, like this. Now okay, now what I am saying is this, because whenever flux is linking with this winding, EMF is induced. This EMF E1 is induced. Okay, Same flux will go and link with this winding. Here EMF it is induced, and because of this E2, current will flow in a such a way direction that because of I2, whatever pi2 will come, that has to oppose your previous flux. So your I2 is flowing like this. It is pi2 is coming like this. It is linking with your what? It is linking with your primary winding once again. So once again EMF will come into picture. Once again EMF will come into picture. Nothing but E2 dash. So corresponding to that EMF, once again current will flow, so that flux pi dash will come, which will oppose previous flux pi 2. That means pi dash should be upwards. So if I want pi dash should be upwards means where your current might have entered. Where your current might have entered, I'm asking you, where your current might have entered. Where your current might have entered here, okay? Like this. It is entering at front end, leaving back end, like this, okay? So this is a discussion we already made. Now I'm asking a very simple question. So V1 is connected here, EMF is induced here, that is okay. If you want to know the polarity of induced EMF V1 according to Lenz's law, what Lenz's law will say? Because of see, actually this is sequence. V1 is connected, IMU is connected, V1 is connected, IMU came, pi came, EMF V1 came. Because of EMF E1, some X current is flowing. X current is flowing. This X current will flow because of this X current. You will get some Y flux. This Y flux will oppose your main flux. This will oppose your flux, right? This is only simple logic, right? Now tell me, EMF I got up to here, okay. Because of this EMF, you know already direction of your because of I mu, you got some pi flux, no? That is this. I mean, I can say that I mu is flowing like this, entering at front end. So flux is upward like this. This is upward direction. This is the direction of your flux. And because of that flux, I got some EMF. That is okay. But because of that EMF, current will come. That current will flow in such a way that your flux, because of X current, Y flux will come. That Y flux has to oppose this pi. That means this should be downwards. Y flux should be downwards. Y flux should be downwards. If I want Y flux should be downwards like this, downwards, where your X current might have entered, observe clearly. Y is downwards. Where your Y current has to enter? Back end. Back end means this one. That means it has to enter like this. Initially, I'll write once again clearly. Please try to follow. Please, okay. Because of I mu, this flux pi, I mu is flowing like this. Okay, flux pi is coming. It is upwards. Your current is entering like this. Flux is upwards. This is what I can say. Flux pi. And EMF I got here. EMF is induced. Because of this EMF, current will come. Because of this current, flux will come. This Y flux has to oppose your this flux. Therefore, let me draw that Y flux should be downwards. This Y flux. Downwards means where current might have entered, your X current, where it has to enter. It has to enter back end. Actually, you know this is about front end. This is about back end. So it has to enter back end means it has to enter here. It might have entered here. That means it is entering at back end, leaving at front end. See, entered back end, leaving at front end. This is X current. Okay. We already assumed dot here, that is okay, that is different case, dot here. Okay, now tell me, and you are going to have some EMF induced. I'll write that EMF as EMF here. Observe now clearly. Because of voltage V1, IMU is coming like this. Because of this flux EMF you got E1. Because of this EMF I got X current. That current is flowing in this direction, opposite. Okay. Always you know which one is more, V1 is more or E1 is more. V1 is more than E1. Therefore, this is ultimately this is nothing but resultant current direction. Resultant current direction. Why? Since V1 is greater than E1. So current will flow like this only. Like this only current will flow. But my question, since your X is opposing your IMU, so E1 is opposing your V1, that's why we are writing a symbol here. Okay, V1 is equals to, why I am writing minus symbol means, since I can write here X current, I can say opposes IMU current. Tell me, X current is due to whom? X current is due to E1. IMU current is due to whom? Due to V1. That's why we are writing V1 bar equals to minus C1 bar. Is it clear? So, see guys, please try to understand this. Okay, this concept. Very simple only. Please, if you see once clearly, you can understand. Okay. If you're not able to understand, also nothing problem. So simply, if you know this relation V1 bar equals minus C1 bar, according to lens law, according to lens law only I explain all those things. Lens law only once again I just include here. Separately, I just showed that I just proved that X current opposes IMU current. X current is due to E1, IMU is due to V1. So since X is opposing IMU, E1 is opposing V1. So since they are opposing with each other, I am just using symbol minus. V1 equals to minus C1 bar. This already you know from vector diagrams. Sorry, from waveforms. From waveforms, you just conclude that V1 and E1 displays are 180 degrees. That is also enough. Just try to follow that method is enough. If you want, you can try to understand this one also. Okay. And if you see here also, here E1 always I told you, if a source is there where always current has to leave at it has to enter at minus, it has to leave at plus. Current is entering in a E1 winding. Current is entering here, entering at the back end. See, observe here. Please try to see my hand here. Entering like this. Entering like this current is flowing. See, entering is blue color. That means I can take this whole V1. I can take plus minus. This is what I can say IMU. I can take this total winding as a source. So keeping current is entering from here, it is entering, it is leaving here. So entering means minus symbol, leaving is plus symbol. This one I can say that E1 value. Because of this E1, you are getting IX. This IX is opposing your IMU. Okay, and this is what I can say resultant direction. Why? Since V1 is greater than E1. Okay, please try to follow this.